Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Have you ever wondered why your skeleton is so resilient? Our bones aren't just static supports. They are dynamic, living tissues that constantly reshape themselves based on the physical stress they endure. This biological phenomenon is known as Wolff's Law, which states that bone will adapt to the loads under which it is placed. If loading on a particular bone increases, the bone will remodel itself over time to become stronger to resist that sort of loading. But what if we could apply this same logic to the very ground we walk on? Imagine a city that grows stronger, smarter, and more energetic the more we move through it. This is the promise of piezoelectric pavement, a technology that bridges the gap between human physiology and urban infrastructure. To understand how a sidewalk can act like a bone, we first have to look at the microscopic level of our own bodies. When you run, jump, or even walk, the mechanical stress applied to your bones creates tiny electrical charges. This is because bone is a piezoelectric material. In the world of physics, piezoelectricity refers to the ability of certain materials to generate an electric spark when subjected to mechanical pressure. In your body, these tiny sparks serve as a biological signal. They tell cells called osteoblasts to build more bone in high-stress areas. This is exactly why athletes have denser bones than sedentary individuals. It is nature's way of optimizing resources. It builds where it is needed and saves energy where it isn't. Engineers are now taking this exact blueprint and applying it to the concrete jungles of our modern world. Traditional infrastructure is passive and sacrificial. It wears down over time under the weight of traffic without giving anything back. However, by embedding piezoelectric sensors and tiles into high-traffic areas like subway stations, shopping malls, and busy intersections, we can turn the kinetic energy of millions of footsteps into a sustainable source of electricity. Every time a pedestrian steps on one of these specialized tiles, the internal crystal structure is compressed, and a small amount of pressure is converted into a microwatt of power. While a single footstep might not seem like much, the cumulative effect in a high-density city like London, Tokyo, or New York is staggering. In these environments, the bone remodeling logic comes into play perfectly. Just as bone grows densest where the load is highest, urban planners can identify high-stress zones in the city grid. By installing piezoelectric arrays in these specific locations, the city effectively remodels its energy output to match its human activity. We are moving toward a future where the city behaves less like a rigid machine and more like a biological organism that feeds on the movement of its inhabitants. But the connection to bone logic goes even deeper than just energy generation. Modern research is looking into self-healing pavements that, much like bone, can repair microscopic cracks using mineral-secreting bacteria or encapsulated polymers triggered by the same mechanical stresses that harvest energy. This creates a feedback loop where the most used paths are also the most reinforced and the most productive. It challenges our traditional view of maintenance. Instead of traffic being the enemy of the road, traffic becomes the lifeblood of the road's durability and power. We are essentially building a nervous system for our streets, one that knows where it is being used and responds by generating power and maintaining its own structural integrity. Of course, we aren't quite there yet on a global scale. The current challenges involve the efficiency of energy conversion and the initial cost of these smart materials. Piezoelectric ceramics can be brittle, and the electronics required to harvest and store this energy must be protected from the elements. However, as material science advances, specifically with the development of flexible piezoelectric polymers and organic composites, the integration into our streets is becoming more viable every day. We are already seeing successful pilot projects in train stations where the footsteps of commuters power the very LED lights and information displays they use to navigate. By looking at our own skeletons, we are finding a more sustainable way to build the world around us. We are learning that the most efficient systems are those that respond dynamically to their environment rather than resisting it. The piezoelectric pavement is a testament to the power of biomimicry, the practice of looking to nature for solutions to complex human problems. As we face global energy crises and the need for smarter urban planning, the logic of bone remodeling provides a clear, biological path forward. Our future cities won't just be places where we live. They will be living systems that breathe, adapt, and power themselves through the simple act of us being there. The city of the future is under your feet. For more incredible facts like this, don't forget to subscribe and turn on notifications.